investigation.
Wait, I'm not ready yet. Okay, I'm ready now. Hey, where are you guys? Let's go find them. Hey bro, our physics assignment are remember.
I want coffee first.
Our physics assignment is more important. Come on now. Go, thumbs up. Hey, still got time to take selfie ah? We still got physics investigation to do ah. Come on now, no time now. Come on. Okay, so now everyone is finally here. Let's start our physics investigation.
I'm Qistina.
I'm Joshua.
I'm Alan. And I'm Derek.
And our physics investigation will be about regenerative braking system.
Let's go!
The conventional braking system that is used in most cars is easy to operate and efficient in stopping the car. It has saved many lives and could have saved more lives if people just remember to press the brake pedal. However, this braking system is not perfect. Every time you step on your car's brake, all the energy used to speed up your car is wasted. Physics tells us that energy cannot be destroyed. So, when your car slows down, the kinetic energy that was propelling it forward has to go somewhere. Most of it simply dissipates as heat and becomes useless. That energy, which could have been used to do work, is essentially wasted. Is there anything that you, the driver, can do to stop wasting this energy? Not really. In most cars, it's the inevitable byproduct of braking, and there is no way you can drive a car without occasionally hitting the brakes. But automotive engineers given this problem a lot of thought and have come up with braking system that can recapture the car's batteries. This system is called regenerative braking.
The most common form of regenerative brake involves an electric motor as an electric generator. So basically, vehicles driven by electric motors use the motor as a generator when using regenerative braking. It is operated as a generator during braking, and its output is supplied to an electrical load. So this concept of generator and motor is based upon two laws, that is Faraday's law and also Lenz's law. Faraday's law explains the working principle of most of the electrical motors, generators, electrical transformers, and also inductors. This law shows the relationship between electric circuit and magnetic field. What Faraday did, he performed experiments and found that an electromotive force, EMF, is induced in circuit when there's a change in magnetic flux. And this induced EMF is proportional to the rate of change of the flux linkage.
As you can see on the diagram, there's a permanent magnet bar and a coil connected to a galvanometer. So in the far left of the diagram, we can see the north pole of the magnet is being moved into the coil. As a result, we could see the needle of the galvanometer deflecting, which means a small current is produced. Same thing happens when it is being pulled away from the coil, except the direction of the current is reversed. However, if we hold the magnet stationary, what do you think will happen? Exactly nothing. As shown in the far right of the diagram, how is this possible? Although the stationary magnet might produce a large magnetic field, no EMF can be induced because the flux through the coil is not changing. This proves that as long as the magnet keeps moving, current will definitely flow.
So while Faraday's law tells us the magnitude of the EMF produced, Lenz's law tells us the direction the current will flow. It states that the direction is always such that it will oppose the change in flux which produced it. And this means that any magnetic field produced by an induced current will be in the opposite direction to the change in the original field. Let's look at the diagram for an example.
As we all know, when north pole of the magnet is approaching towards the coil, the magnetic flux linking to the coil increases. So according to Faraday's law, when there's a change in flux, an EMF and hence current is induced in the coil, and this current will create its own magnetic field. Now, according to Lenz's law, this magnetic field created will oppose its own, or we can say opposes the increase in flux through the coil, and this is possible only if approaching coil side attains north polarity. As we know, similar poles repel each other. Once we know the magnetic polarity of the coil side, we can easily determine the direction of the induced current by applying right-hand grip rule.
Now that you have listened to Qistina's explanation on Faraday and Lenz's law, you know that electric motor that drives the car's wheels plays a major part during braking. Before braking the car, the current runs in one direction from the car batteries to the motor, which is changed to kinetic energy as shown in the energy flow diagram. And so when the brake pedal is pressed, the regeneration braking circuit switches the motor so that it now operates in reverse to counter the direction of the wheels. This reversal actually makes it perform like a power generator on dynamo that produces electrical energy. The electricity developed is routed towards the car's storage batteries to recharge them. However, at higher speed, regenerative brakes still require the existence of conventional brake system to be applied as a backup, as the braking system cannot convert the kinetic energy to electrical energy fast enough to quickly slow down the car, especially during the emergency brake. This means that energy is still lost through friction and heat energy.
So now we come to the advantages of using regenerative braking system in our real life. First of all, it improves the fuel economy of the vehicles. Regenerative braking is fuel efficient as the fuel consumed by the vehicles can be dramatically reduced. The International Journal of Vehicle Design noted that in the year 2018, the fuel economy covering the new European driving cycle was improved by 25%. It allows traditional friction-based brakes. A friction braking system is included with a regenerative braking system to ensure the car can be stopped stationarily in time. Once the energy is captured by the regenerative brakes, the energy is used to recharge the battery in the vehicles. As this energy will normally be lost, the car can experience a prolonged charge while driving. Moreover, it reduces the wear and tear on the braking system. Because an electric drivetrain is a part of this system, the greater efficiency given to the braking system allows for a reduced level of wear on the braking system on the car. It is also quiet and produces no chemical pollution, as carbon dioxide emission is obviously reduced through the implementation of regenerative braking system. This statistic can clearly show that the carbon intensity of electric cars over the past 5 years has dramatically decreased. Now let us zoom into the application of the regenerative braking system.
We have the disadvantages too. So, you think regenerative braking is good, it's flawless? Now, I don't think so. Alan had some good points, but everything has a bad side. Okay, hear me out. One, it can be costly and not affordable for some people. I mean, the cost of components, the engineering, manufacturing, and installing is kind of high. Two, it needs the assistance of friction brake.
Note that friction brake is a common brake we use in most cars now, like the conventional brake. So the regenerative braking effect actually drops off at a lower speed. Therefore, the friction brake is actually still required in order to bring the vehicle to a complete halt. And basically, some energy is still lost as heat. 3. This system actually increases the total weight of vehicle probably around 25 to 30 kilograms, and that is quite heavy, hence decreasing the car's fuel efficiency. And 4, regenerative braking is mostly applied to a two-wheel drive brake system. This picture shows that this braking system is only applied to a pair of wheels. As you step on the brake pedal and the regenerative brake kicks in, negative torque is applied to the drive wheels. Therefore, in a two-wheel drive vehicle, negative torque is applied to the wheels with brakes, while the wheels with no brakes are able to spin freely. So this uneven distribution of negative torque causes uneven tire and brake wear. And this could potentially cause skidding on the wheels with brakes.
The main idea of the application of regenerative braking system is to recover the kinetic energy lost during braking. In real life, the regenerative braking system is applied on hybrid vehicles and electric cars. These technologies have been implemented by automakers companies such as Honda, Toyota, Mercedes-Benz, Volkswagen, BMW, Tesla, and so on in their hybrid cars and electric cars manufacturing. For example, Toyota Supra HR-V hybrid race car had won the 24 hours Tokaishi Endurance Race in July 2007. Toyota was the first car manufacturer to enter a hybrid vehicle at the Tokaishi 24-hour Endurance Race. Besides that, regenerative braking system is also used in some elevator and crane motor. Regenerative lift saves electrical energy under certain speed and distance. This can greatly reduce the heat dissipation arising from the lift braking, thus saving the overall power consumption of the lift.
When lifting a fully loaded car in a traction elevator application, electrical power is delivered from the building utility to the elevator system. However, when descending, that same fully loaded car will regenerate energy. In other words, the stored energy in the mechanical system is converted back into electrical energy. Historically, for VFD applications, this energy was shunted across a braking resistor and dissipated as heat. This resulted in two problems. First, the heat represented wasted energy. The costs to a building owner could be significant depending on the size, duty, and number of elevators in the building. Second, the additional heat in the machine room often resulted in additional cooling costs. There is a better, greener alternative. KEB's R6 line regenerative drive replaces the traditional braking resistor and can be used alongside the elevator drive. When an overhauling situation exists, the R6 regen unit goes active and commutates energy back onto the building to be consumed by other loads, such as lighting or HVAC. The R6 is very compact and is available in capacities up to 500 amps. The smaller units can be used on both 208-volt and 460-volt installations and automatically detect the mains voltage and frequency. The R6 units require little adjustment and are easy to use. They feature internal DC fuses and programmable I/O. For applications that need to meet IEEE 519 power quality standards, passive KEB harmonic filters can be used to meet the most stringent levels. In addition to saving energy, the R6 line regen units save money too. For efficient gearless systems, the ROI can be less than 2 years.
Apart from that, regenerative braking systems are used in electric railway vehicles such as London Underground and Virgin Train. The train is slowed by the climb and then lifts down the slope, So the kinetic energy is converted into the gravitational potential energy in the station. Electricity generated by the regenerative braking may be fed back into the traction power supply stored in the line-side storage system for later use. This picture can briefly show how regenerative braking system works in electric railway vehicles.
Now I'm going to talk about the limitation of regenerative braking. Everything has limitations due to humans' incapability and the lack of advanced technology. Hopefully in the future, these limitations are resolved to provide better assistance to us. Since we're on the topic of limitations, just for some general knowledge, these followings are one of the few humans' limitations up to this day. The fastest we could run is 10.5 meters per second. The heaviest we can lift is 1000 pounds. The most we can remember is 1 million gigabytes. And the smartest we can get is 198 IQ. One of the limitations is the limited capacity of the energy storage system and provide the output power of the electric motor. This means that it can't recharge as much as it can discharge. Take your daily use of phone, for example. It is easy to finish the battery, but takes a long time to charge it to full every time.
Another limitation to regenerative braking is that it's ineffective if the speed is too low. Thus, the regenerative braking is insignificant when you are driving slow. This is because the vehicle must be fast enough to generate a voltage larger than the power bank to enable charging to occur. When you are using the brake at low speed, the change in magnetic flux will be very small, thus the voltage produced doesn't contribute much into the charging.
Another limitation is the strength of regenerative braking, which is incomparable to disc brake. Regenerative braking is unable to reduce the speed of the car as fast as disc brake. This is very dangerous in extreme conditions as it couldn't stop the car in time and results in a collision. Nothing is flawless in this world except for the word itself. Anyways, regenerative braking do have some room for improvement, which can further enhance the performance of it. One of the modifications is regenerative braking can install supercapacitor in it. Supercapacitor is a high capacity capacitor with capacitance level higher than normal capacitor. Thus, they can recharge and discharge 100 times faster than normal capacitor. Anyways, if you couldn't catch what I said just now, I'll just summarize it. Basically, supercapacitor is like as you can see, it can charge fast and a lot and discharge a lot and fast. Sadly, it wasn't enough.
Other than that, solid-state battery technology may also be implemented in regenerative braking. Solid-state battery is as its name suggests. It is a battery which uses solid electrode and electrolyte instead of the usual liquid polymer electrolyte. I'm pretty sure chemistry students would know that, right? Anyways, you may ask, what's so special about it? Well, it is a battery that contains high energy density, which means the amount of energy stored per unit volume. This shows that it contains high amount of energy compared to normal battery. Not only that, it is said to have a high recharge rate, which may prove useful to regenerative braking.
How to make it not stand out? Three idiots.
Sequence will be about regenerative braking system.
One of the limitation in the
This can greatly reduce the heat dissipation arising from the leaf braking, thus saving overall consumption of 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 thus saving the overall power consumption. Thus saving the overall power consumed. Wait.
Tells us the direction of the current, depth.
A generator when using generative braking. It is
Any magnetic field produced by an induced current will be in the opposite direction to the change in the original field.